Hello and welcome Math 140 students. We're going to pick up on page 15. So we are going to continue our section in 4.3, which is our word problems with elimination. So number 12 reads, at the end of spring break, Lucy left the beach and drove back towards home, driving at a rate of 40 miles per hour. Lucy's friend left the beach for home 30 minutes, half an hour later, and drove 50 miles per hour. How long did it take Lucy's friend to catch up to Lucy? So you can think of it as we have Lucy. She's here at the beach, and she's going to be driving along a road, versus we have Lucy's friend, who's also going to be driving along the road. And they're going to be traveling at a different rate. So here they're both going to start off going to the beach, and they're driving. But it says that Lucy in particular, she is driving at 40 miles per hour. So our rate is 40 for Lucy. Now the friend for Lucy, they said that the friend drives 50 miles per hour. So the rate is going to be 50 miles per hour. And at some point, the friend is going to catch up to Lucy. So let's say the point is here where they meet up. So they would have the same distance. So it looks like this type of problem, by looking at the diagram, I have a distance, a rate, and I have a time. So my distance, my rate, and my time. So the two things that I'm talking about is I have Lucy and we have her friend. I know that the rate that Lucy goes would be going 40 miles per hour. The rate that the friend would be going is 50 miles per hour. Now, we also know something about the time. It specifically says that the friend left 30 minutes later. So let's think about this. If I have 30 minutes, that is equal to 1/2 hour. Well, 1/2 hour is the same as a 0.5 hour. So let's say for time, we have X amount that Lucy drove. So then the time that the friend drove would be an X minus a 0.5, since it's a 0.5 hour difference. So I'm going to go ahead and make sure that I write it as a 0.5. So I know I'm talking about a 0.5. And the distance here would be the same amount of distance eventually. So Lucy's driving at a slower rate, the friend's driving at a faster rate, but eventually that 30-minute time difference isn't going to matter much because they're going to meet up at the same time. So from Lucy's equation, we know that distance is equal to 40 times x. From the friend, the distance is equal to 50 times my x minus a 0.5. Well, here I can go ahead and distribute that 50. So I can get that distance is equal to a 50x, and a 0.5 times 50 is going to give you a 25. So now I have my two distances. So now I can set them both equal to each other. So I have the distance of 40x. It's going to be the same as my other distance that I have. So notice how these two both are equal to distance. So I'm able to set both those equations equal to 0. So then from here, I'm going to subtract 50x from both sides. So I can get a negative 10x is equal to a negative 25. I'm going to divide both sides by a negative 10. So that x is equal to, and if I have a negative 25 divided by a negative 10, I'm going to get 2.5. So remember that x represented the time that Lucy goes. So Lucy takes 2.5 hours? Well, it tells me that the friend takes, well, remember, it's half an hour less. So here, if I have that x is equal to 2.5, and the friend's time is x minus a 0.5, well then 2.5 minus my 0.05 is really going to give me 2. So it takes the friend 2 hours. And that's what we're really looking for here, right? How long did it take for Lucy's friend to catch up? Well, it took Lucy's friend 2 hours to catch up. For number 13, Brandon has a cup of quarters and dimes with a total value of $3.80. The number of quarters is 4 less than twice the number of dimes. How many quarters and how many dimes does Brandon have? So there are two things that we're mixing here. We have quarters, and they are being mixed with dimes. And it's going to give me my total. So the two equations that I want to figure out is the amount, and I also want the money times my amount. So equation number 1, well, I have my quarters, let's call them Q, plus my dimes, let's call them D's, is equal to my total. And it specifically says that my total is going to be 380. So my amount for money is going to be $380. So the number of quarters, so the money times the amount is going to be how much each is worth. So let's think about this for just a little bit. I know that I want my amount times my money. So how much is each quarter? Well, the money part for each quarter is how much it's worth. Each quarter is worth 25 cents. Well, how much would each dime be? Well, each dime would be 10 cents. So the amount of quarters, that's how I got my 0.25. The amount of dimes, that's how I got the 0.10. So 0.25Q plus 0.10D is equal to my $3.80. So I have my money times the amount, which gives me my total money that I have. Now, the second sentence is going to give me my second equation. So it specifically says that the number of quarters, so here I'm talking about the amount, and I'm talking about quarters, and it's equal to. So Q is equal to 4 less than, so that's subtract 4, because that's subtraction, twice the dime, so 2D. So this would be a 2D minus 4, okay? So now that I have that, I'm going to go ahead and do a substitution. So in that first equation, I know that I have 0.25Q plus a 0.10D is equal to $3.80. Now, since I have this Q value, that is what I'm going to be plugging into. So I have that 0.25, and that Q value that I'm plugging in is all of this. So that would be the 2D minus 4 plus the 0.10D is equal to my $3.80. So now 0.25 times 2 is going to give me 0.5. And 0.25 times 4 is going to give me a 1. And it's still equal to $3.80. Now I can combine 0.5 and 0.10. And that's going to give me a 0.60 minus 1 is equal to $3.80. So I'm going to go ahead and add 1 to both sides. So that 0.6D is equal to $4.80. So now divide by a 0.6 on both sides. So that $4.80 divided by a 0.6 is going to give me 8. So I know that D represented the amount of dimes. So I have 8 dimes. So now I want to specifically find out how many quarters I have. Well, I can do that by plugging it into this equation. I have that the amount of quarters is equal to 2D minus 4. And here my D value is 8. So 2 times 8 minus 4 is going to give me 12. So I have 8 dimes and I have 12 quarters. They're going to add up together to give me a total value of $3.80. For number 14, it says tickets for the community fair cost $12 for adults and $5 for children. On the first day of the fair, 312 tickets were sold for a total of 2,204. How many adult tickets and how many child tickets were sold? So there are two things we're talking about. We're talking about the adult tickets and we're talking about the child tickets. So we have adult plus the child is equal to your total. So that's what we're going to be thinking about each time. So here, let's just call this the X for adult. And for child, let's call that the Y variable. And all of that is going to equal your total. So now we're talking about money. So here, when we talk about money, I have $12 for adults. So we have our money amount, right? It says $12 for adults and also have our $5 for our children. And we have how much is going to cost us. The other amount that we know here that we can play around with is the total just tickets. So you can think as your first equation as just your straight amount. So I would have your X plus the Y is equal to your total amount, which is 312 if I'm just thinking without the money. My second equation is going to be my money times the amount. So I'm multiplying. So here X represents my adult tickets, which is $12. And so each child ticket is $5. And the total amount of money is $2,204. So now I have my two equations. And now what I would like to do, what might be the easiest thing to do here, is I'm going to go ahead and just solve for the Y variable by itself. So I would get Y is equal to 312 minus X. All I did was subtract X from both sides. So now I can do a substitution. So I have a 12X plus a 5Y is equal to 2,204. And I'm going to substitute in for the Y variable. So I have a 12X plus a 5. And that Y variable, I am plugging in 312 minus X is equal to 2204. So then 12X plus, and this is where I'm going to distribute. So 5 times 312 is 1560 minus my 5X is equal to 2204. Now I'm going to add 12X and negative 5x. So then 12 minus 5 is going to give me a 7x. So now I'm going to subtract 1560 from both sides. So that 7x is equal to 2204 minus 1560, which is 644. So I have 7x is equal to 644. So to get the x by itself, I have to divide both sides by 7. So 644 divided by 7 gives me 92. Remember, x represented the adult tickets. So here I have 92 adult tickets. Now I want to find out my child tickets. So for my child tickets, that would be representing my y equation. So here I already have that y is equal to 312 minus x, and I just told you that x is equal to 92, so I'm going to plug that in. So y is equal to 312 minus 92. And so I end up with y equaling 220. And remember, this is my adult tickets, and this is my child tickets. So now I know that my child tickets, I have 220 child tickets. And so that ends up becoming my final answer. Okay, so for number 15, it says Angela invested $4,000 into two accounts. One account paid 4% interest and the other paid 9% interest. He earned 6% interest on total investments. How much money did he put into each account? So I know the first sentence here is going to give me my amount. So here I have two accounts, so let's just call them X and Y. So X plus Y represent my first accounts, and it's going to equal to 4,000. And better yet, let me rewrite that. I'm going to say my first account plus my second account is equal to my total. So I don't know what my first account is, so call that X. I don't know what my second account is, so let's call that Y. But the total here is going to be 4,000. That is the total that I have. It says one account paid 4% interest. So if I'm trying to write 4% as a decimal, that means I'm going to move the decimal over twice. So it ends up becoming a 0.04. So let's just go ahead and say the green one is a 0.04. And so the second account that I have here is 9%. So 9% can be written as a 0.09, so 0.09y. And it says that he earned 6% on the total investment. So the 6% can be written as a 0.06, and it's going to be multiplied by 4,000. So now I have my equation. What I can do here is I can go ahead and just make that second line a little bit nicer just by multiplying here. So I really have this 0.04x plus my 0.09y and it's equal to, this is where I'm going to multiply 0.06 times 4,000 is equal to 240. So now I'm going to get one of these variables by itself. Let's say y. So that y is equal to a 4,000 minus x. So I'm going to substitute in this 4,000 minus x into this y variable here. So that I have 0.04x plus 0.09, and that y variable now becomes 4,000 minus x is equal to 240. So now to distribute, 0.09 times 4,000 gives me 360 minus a 0.09x is equal to 240. Now what I can do is I can combine my x's together. So I have a 0.04 minus a 0.09, which is going to give me a negative, So 0.04x minus a 0.09x is going to give me a negative 0.05x. And I still have my 360 is equal to 240. So I'm going to go ahead and subtract 360 from both sides. So that 0.05x is equal to 240 minus 360, which is a negative 120. And don't forget that 0.05x was negative. So when I divide, it should be a negative 0.05. So when I divide a negative divide by a negative, so negative 120 divided by negative 0.05, I get 2,400. And x represented the amount in the first account, that's 4%. So account with 4%, she had a total amount of 2,400. The account with 9% had, so now you have to kind of fill in the blank here, right? How much money did she invest in that, or did he invest in that 9% account? Well, you already know that y is equal to 4,000 minus x. And you know what x is equal to. So 4,000 minus that 2,400. So that 4,000 minus 2,400 will give you 1,600. So 1,600 was invested in the account with 9%. And that is the end of this section. So it's not like these problems are difficult, but these problems are long. So you just have to see it all the way through from beginning to end. All right, thank you guys.